Hello everyone, welcome to today's Novedge webinar, Reverse Engineering Scan Meshes and SolidWorks. Power surfacing reverse engineering for SolidWorks makes it easy to reverse engineer even complex scan meshes, high poly meshes, and topology optimization meshes inside of SolidWorks. It provides unparalleled accuracy in capturing even the smallest details without exploding the file size. And because it works inside of SolidWorks, the resulting geometry is fully SolidWorks compliant, so you can apply all of your SolidWorks functionality to your resulting model. Today's webinar presenter, Gary Crocker, has a background in mathematics and computer and systems engineering. He founded IntegrityWare in 2002 and then started the Empower software division of IntegrityWare to focus on end-user products after welcoming David Gill on board. By the way, David Gill is with us today backstage. And during that time, Empower Software developed plugin products for 3ds Max, Maya, Rhino, Modo, and SolidWorks. In 2017, they also released several standalone products based on their Cyborg 3D platform. Both Gary and David are here today with us, so great. We're very excited to get a chance to have them with us for an entire hour and pick their brain if we need to. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions for every designer's needs. So you can see now the Empower software page. We also have Cyborg 3D and other Empower products, so check it out at novedge.com. And for more daily software news and promotions, come find us on Facebook, Google+, Twitter, and Instagram. Our next Novedge webinar will be on Atlantis 7. And last but not least, today's webinar will be recorded and posted later on today on YouTube and Vimeo. Just search for Novedge. And now this is the time where I share Gary's screen. So give me a few seconds to allow the transition. Okay, Gary, you should be able to share your screen now and take it away from me.
All right, can you see the presentation?
Yes, I can.
All right, welcome everybody. We are very excited about Power Surfacing 5.0. In that we have introduced some fairly automatic technologies for being able to create a SolidWorks solid geometry surfaces from scan meshes, ZBrush meshes, and Topology Optimization meshes as well. We demonstrated this at last year's SolidWorks World, and there was somebody there doing a presentation, and they compared our technology. They sent us a small dragon, and they compared our technology to a couple of other technologies. And the bottom line is that our surfaces, once they were inside of SolidWorks and the SolidWorks file size, was at least an order of magnitude smaller than the other two solutions for that particular model. Meaning that ours was 20 megabytes, and theirs was over 200, and at one point almost a gigabyte. And so we're very excited. We think this is a very big innovation in the field of reverse engineering. You know, we've been working with several customers that do figurines and things like that, as well as ZBrush, who do design. And we've also been working with the Topology Optimization team in SolidWorks. So let me kind of introduce what we have here, give you some quick overview, and then we'll get into some live demos. So this is Power Surfacing 5.0. We can take a mesh into SolidWorks in a matter of minutes, not hours or days. Any of you who are familiar with the old, you know, our previous version of Power Surfacing, it pretty much was manually based. In other words, you had to lay out your mesh by drawing on it, and we had some automated tools, but it was still kind of manual. And so this new technique that we're going to show you today is very much more automatic. And we believe we have a solution that nobody else has in terms of the complexity, the detail, as well as the size and complexity of the model. So here's some examples of some things that we've reverse engineered and pulled into SolidWorks figurines and things like that. We think we're a leader in picking up the fine details on the mesh, even like the little wrinkles and that sort of thing on the mesh. We have some tools which we think the process that we have put together it really makes it fairly easy. There's a fairly easy workflow to this. So we have a quad wrap tool which will automatically retopologize a scan mesh and follow the curvature. So here you see a 3% quad wrap, 3% being sort of the relative quad size relative to the whole model. And here you can see a 2% quad wrap. And if you'll notice, the quads tend to follow the curvature of the mesh itself. So in other words, the geometry orientation. So for example, if you have an arm or these things sticking out, you'll see that the mesh flows nicely along them. When we combine quad wrap with shrink wrap, which is sort of a patented technology that we have, we're able to bring out the finer details in the mesh. So for example, with no shrink wrap, I believe that like 2%, that is what the model looks like. When we apply one level of shrink wrap, we start picking up some of the detail in this particular model. And if we go up higher levels, you can see we're picking up a lot of the detail at level 2, a lot of the surface detail in level 2. And the interesting thing about this is sometimes you may want level 0 and you don't want to pick up all the detail in the mesh, but you want something smoother, or you may want to actually pick up all of that surface detail. It really depends on what you're doing for an application. And so we think our tools are ideally suited to help you do that. So here's kind of a quick run through of our quad wrap and shrink wrap tools. So we're going to start at 4%, and probably that's a little big. 1%, we can go a little smaller than that, I think. So we're going to settle on like 1.75% here. And we're going to show it in subdivision mode. And then we're going to go to 2 levels of shrink wrap on that. And you can see the definition increased drastically. And here's the surface breakdown. It's a very nice surface breakdown, produces a nice verified solid that you can use inside of SolidWorks to actually apply some features. And we've already got some features here that you can take a look at. So it produces a nice verified solid. So that's kind of the quick and easy workflow. Sometimes, if you have fairly clean meshes and clean models, it literally only takes 2-3 minutes to get through it. One of the things that we've done is we've implemented something called curvature-driven surface knot density, which produces very lightweight surfaces, lightweight models with high accuracy, and it's highly adaptive to, so in other words, you're going to put more geometry and more data where you need it and less where you don't. So this is a model, and you can actually show this model when you're in. We'll show you this model live in a little while. The blue areas, and this is at shrink wrap level 2, the blue areas are where it uses a full level 2. So it needs all of the detail there. The orange areas are where it only has 1 level of shrink wrap, and the lighter color areas are where it can capture that detail without any extra subdivisions. So what that produces in terms of a surface is something that looks like this. So for example, there's a level 0 surface on the cheek there, which has a very low, these are the knot densities, that basically it shows the level of geometry on the surface. And there's a level 1 surface, and there's a level 2 surface. So you can see that the knot density increases. Now, if we had to do this whole model at level 2 in order to get the detail in that particular area of the eye, the weight on it would increase by approximately a factor of 8. So that's how important it is to do these things at different levels. And we also have a lot of tools in there to help you deal with the real world problems that you come across when you get scan meshes. One of the things that you can have is you can have worn or damaged area on the original object. So the object itself could have issues even before you scan it. You could have 3D scan anomalies. For example, there could be microscopic holes and bubbling here along this edge. You can see, I'm sure they didn't intend for this to happen, but the software, as well as the scanners being what they are and the technology being what they are, you often get this sort of thing. Here's a razor thin edge overlap, and we'll show you a little bit of that in the video in a second. And there's what we call a false bridge. There's like false bridges as well as false like little holes and stuff that you really shouldn't have been there, and you really don't want them there, but the scanner, the scan software, when it was putting it together, happened to bridge those two things together. So let's take a look at our technology for doing that. And there's two ways to handle these problems. One is to directly edit the original scan mesh. And so then in that case, if you have a scan mesh with, say, 5 million polygons and you're trying to directly edit it, it's very tedious, very difficult job at times, unless it depends on your tools. But if you actually have to go in and fill holes and all that sort of stuff, it's very difficult. The other option is to edit the actual quad-wrapped retopologized mesh. And that is a much lower detailed mesh, and it's much easier to do intelligent things with the shape with this. And so we actually allow you to do both of these options. So let's show some examples here. So we have, the first process that we typically do after we quad wrap is to isolate open edges. Then this will quickly identify any mesh anomalies that are on there. And so let's take a look at that here. So here we had a little hole that we filled in there, and then we have a couple of more areas. In that area there is a like a little thing going in, and here we have a little pocket that's one of those worn edges areas that we just showed you a minute ago. And so what we're going to do is take and just select some of the geometry around it, and then use the bridge and fill it up. And we have a quick fill tool which will fill an area very quickly. Here's that another area, and we're going to use the paint faces tool to pull an array of faces across there, and then we use our fill tool again. And this is that razor edge that I was showing you before, and you can see we've produced a nice clean edge from that razor edge with very little effort. Sometimes you need to add a little more detail. The isolate open edges is really convenient because it allows you to get into a particular area and reduce the sort of the graphics redraw issues and so on. And so here what we're doing is we've subdivided and added some detail to actually pick up the end of that thumb in a much better way. Once we have a closed mesh and we've done the shrink wrap on it, sometimes what you need to do is to isolate self-intersections, because this is a tool that we have which will show both self-intersections and sort of potential self-intersections where the surface is getting kind of sharp, like it has a high degree of bend in it. And so here we're going to go level 1, and I'm going to isolate the self-intersections. And one of the things we can do there is simply remove the constraints on those things. Here we have an actual true self-intersection, so we went ahead and deleted it, and then we just filled that area again to remove the self-intersection. So that was fairly easy to do, and you can see here we have the sort of the final fairly complicated model. This is the model of from Russia. This is the worker revolting. Okay, so I'm just going to run through some different meshes that we've run through and give you some examples so that, if you have one of these particular fields, you can see the sort of things we can do. Um, we can wrap up mechanical things and produce SolidWorks bodies. We do figurines and animals. We can do architectural stuff. Actually, we have customers that are designing bricks, which is really cool. And they use our stuff to produce bricks. We can do medical things. Industrial type of things. This is actually one of our customers that uses the reverse engineering to take a scan of a normal car and produce a NASCAR out of it. Okay, topology optimization is becoming a very big deal in both SolidWorks and other areas. And we have some tools that will help you out with that. There's sort of two different things that we do. One of them is we can use that sort of automatic quad wrap process to get you a quick solid so you can run it through after you've done the topology optimization. So here's an example of a topology optimized thing. And there we've done the quad wrap and produced a solid, and you can run that through your analysis and see if that's going to work. So it gives you a way to quickly get back through the system to see that if the result you have is correct. This is probably not something that you're going to actually manufacture there, but it does give you a quick way to do it. You're probably going to want to re-engineer that a little bit, a little bit differently, and we'll show you that in the next slide. So here's another example. All right, now here we actually use the topology study mesh as a template to design a part. The interesting thing is that these topology study meshes tend to be very much like webs, like a spider web sort of thing that holds things together, and it tends to be very organic in nature, and our power surfacing is excellent for being able to do that sort of thing. So on the left here, this image on the left is the topology study mesh for a couple of cylindrical shapes, and that have some forces applied to them. And once you do the topology study, you can see the basic connections. And on the right here, we have the re-engineered object that we've produced using our tools. And this, I'll give you this short video here, will kind of give you an idea of how we did it. So first we created a couple of reference cylinders that corresponded to those the big areas there of that. And then we used those, we imported those as reference geometry into power surfacing. And we have this interesting tool called wrap, which allows you to wrap around something and create sort of a little teeny solid around it. It's just a box, and it allows you to specify the orientation, and once it's subdivided, it will be approximately the size of the object that you have wrapped. And see here, and there we kind of fast forwarded a little bit and done a bunch of them. We can use we're using the insert loops tool to kind of subdivide them, because we're going to bridge these together to get sort of a basic shape, to get those Y joints, which are extremely difficult in traditional modeling tools. Then we're going to open up the ends here, and once we get those ends opened up, we're going to attach them to the cylinders, and we've done it there. And once we do that, then we can adjust, they're constrained to the cylinder, and we can put on transparency mode and adjust the shape to be pretty much what the topology study mesh is. Then we did a delete a knit to convert it, and that produced a single solid with the cylinders. And then we threw on a bunch of SolidWorks features to get back to the original object. So that is a very clean, easy, quick process to reconstruct something from the topology study mesh. And those organic shapes are perfect for power surfacing. We also have been working with ZBrush quite a bit, and we can take their sculptured figurines and produce manufacturable SolidWorks solids fairly easily from them. The nice thing about the ZBrush models is that they don't have a lot of the problems that you typically find in a scan mesh. They're usually very, very clean. So it's a relatively easy problem for us to solve. And that was cool. There's a lion and a dragon wrapped around a ring fighting each other. Here's an example of some detail, surface detail that is on a vase, and we're able to model all of that directly in SolidWorks geometry. Here's a skull ring. And to summarize, we have powerful new tools for reverse engineering complicated meshes. We have an automatic quad wrap tool to quickly retopologize the mesh, so you don't have to do that all manually now. And the interesting part is that it follows the curvature of the geometry. We have a shrink wrap tool, which allows you to capture fine surface detail. And we have adaptive surface density for lightweight SolidWorks bodies, but they still have high detail. And in Power Surfacing 5, we think we have a highly automated and efficient workflow. The high quality, we can produce high quality SolidWorks geometry and capture an amazing level of detail in the models. And the other thing is our models are also fairly lightweight. So this, if you're dealing with bringing in any kind of organic shapes, I think we have a phenomenal solution. And so we're going to start the live part of the demo now. Is this probably a good time? Are there any questions before we get into the live part?
Yes, there's a couple of questions. The first is reverse engineering only available in SolidWorks or also other software like Rhino?
We do have a standalone product that does the similar thing and will export a step file. It's the Cyborg 3D Mesh to CAD product, which is on our NPower website as well. So if you go to that same website, you'll see Cyborg 3D Mesh to CAD, and we have just released that. And we actually haven't even sent out a press release for it yet. We're still kind of working on some videos to finish that up, but that is available on the outside. So basically these tools, instead of being inside of SolidWorks, are outside of it as well, just a different user interface.
Yeah,
okay?
I just shared the link of Cyborg 3D Mesh to CAD on our website as well. And the second question is, what is the continuity conditions between the quads produced? For instance, you know, I can assign you the question so you can read it for yourself. That would be
I think I know the answer to that question. And the answer is that everything is G2.
Yeah.
So it's curvature continuous.
Okay.
Unless you go in there and actually try and change it by putting a crease edge in or something, it's going to be automatically G2 continuous.
And what's the importance of having NURBS models when it comes to manufacturing?
You'll have to ask all the CAD guys. I mean, you can 3D print using meshes, but typically most of the manufacturing is done inside of the CAD model. For example, we work with Disney, and they use different tools, but ZBrush mainly, and then they need to take that to the manufacturing, and so they use our tools to convert that into a manufacturable NURBS-based solid. So that's sort of the typical way it's done in the industry right now.
Thank you, Gary. Last question before we move on to the next section. Can you shell those models in SolidWorks?
Usually. And when
Okay.
I say usually, I mean, uh, if you have a very complicated thing with high surface detail and lots of curvature, then you're going to have areas just like any SolidWorks surface that is too, the curvature is too small. So the ones, some of the ones that I'm going to show you, like the bone here in a minute, and for example, that head model that you saw in the video, you could probably almost certainly shell that, at least at a fairly low size. The other interesting thing is that we do have an offset tool inside of our software that will allow you to offset the original surface and create another body, and that will be an offset of that. And if, for example, there are self-intersection areas, you can use our tools to check that out and fix them. So yeah, there is ways to get around it if it doesn't work. And it really kind of depends on the level of surface detail. And it's just like any SolidWorks surface in that respect.
Thank you, Gary. That works for us.
Okay.
And now we'll, if you have further questions, type them in and we'll address them next. So after this section. So stick around.
Okay.
Stay tuned.
All right, let's do that head sculpture. Okay, so typically scan meshes come in and they may not be oriented quite the way you want. So we have tools that allow you to quickly, as you can see, this is not really oriented that great. So we have tools that will allow you to edit the mesh. And here we're just going to select a little bit of it here, kind of the flat part on the bottom. And that will kind of give us more or less a plane of orientation. And so if we right click here, we can orient that as Y up. So it will take the sort of the average normal of the things that I just selected and orient that to Y up. And you can see that that's pretty much what we've done there. The other thing that we can do is move the selection center to the world origin. So you can see the world origin right up here. And so we're going to move that over so that when we convert this thing, that we will be able to see the graphics nicely, and the bottom plane will be down here, and it will be sitting on top of that bottom plane. So that's a couple of tools that we have in there that allow you to quickly orient things to different areas. So let's go ahead and give you a quick run through of, okay, now we're done editing the mesh and we have our tools back. So we're going to start out trying to quad wrap this at like maybe 3. And I'm going to show the preview. And that probably that's not really picking up a lot of detail. You can see the eyes have all washed out, and things around the hairline have washed out. So that's probably not the best resolution. If we go, let's try 1. And I think we'll end up settling for something around there. And as you use this some, you will get an idea about what the size works the best for your particular models based upon their detail. You typically want to go as low as possible to minimize the number of surfaces. So I'm really picking up pretty good detail in here. I could, you may not think so, but with the shrink wrap tool, I can go a little bit lower, like 1.75, and give that a try. So that's not too bad for now. Let's try it, and we'll see how good we're able to get the actual shape. I'm going to turn it into subdivision mode here for a second. Okay, so now it's subdividing, and if we turn off the edges, you can get an idea. It's still pretty washed out, but you got most of the basic shape there. Then we're going to go into our patented shrink wrap tool, and we're going to pump that up to like 2, and we're going to show the preview. And you should see it in a second or two here. Really pull out all the detail from the mesh. There you go. So now, and what we've done is we haven't actually increased the mesh density. So we have the same mesh, but I have added detail underneath the hood, so to speak, so that I don't need, you know, in other systems where you're doing this sort of thing, you'd have to go finer and finer and finer to pick up all of that detail. But that's not the case with what we're doing here, is we can pick up that detail and sort of embed it so that we can still have a fairly lightweight mesh that we're dealing with. So let me turn on the coloring. I talked about that earlier. And you can see here the blue parts, so the areas where we have the highest subdivision. The orange parts are the second. So the blues would be level 2 of subdivision. Of course, you can see the hair, almost all of it's level 2. The nice flat parts, like the cheek and some of these parts down here, to capture the necessary detail, you really only need 1 level, so it doesn't add the extra information in that area. And so for the orange areas, that's kind of in between. So this is really one of the keys of our technology is how we do this. And let me convert it. Typically, we run isolate open edges. No open edges found. Actually wanted to do that, but let's try. Okay, now the other thing we want to do is we want to check for self-intersections. And there are a couple of areas here where there are self-intersections. One of them is this whole area. There's like a hole in the bottom, and then this whole area up in here where there's a little teeny pocket underneath. I suspect that is an anomaly. There's a small area here where there's some self-intersections, and here. Now we can handle most of these self-intersections simply by removing the constraints on them, and that will smoothen them up. You can see what happened there to those guys. As a matter of fact, it probably has made this one good enough. I could, if I wanted, and let me do this anyways, just to show you how you might do that, is let me grab some faces here. We could say, I really don't want that mess in there. That pocket really wasn't supposed to be there. So I can delete these guys and then go ahead and fill them in. And I'm probably going to want to remove some of the constraints on them so they get nice and round. Still not looking real good. Let me expand selection a second here. Yeah, let me grab this whole area. And then we are going to remove the constraints again. And then we're going to run a relax command on it. And you can see the relax has smoothed it out substantially. And there's other ways to get around these issues. You might even want to, now that those things have collapsed quite a bit, you may want to go in there and, for example, delete these guys and then just quickly refill that hole. So now let's try and let's check for self-intersections again. And if it doesn't have any, it will return to the full model. If it still has a self-intersection, it will show us. No more self-intersection found. Continue isolating. More self-intersections found. Continue isolating. Okay, so I did still have some issues on this one here. Let me remove the constraint. There we go. That smoothed it out quite a bit. Try it again, and we should be good to go after this. Yep. Okay, so it is ready to convert into SolidWorks geometry. So let me click OK here. Yeah, there's a convex vertex found. Now I could go and fix that, but typically that's not a big issue, so I'm just going to convert it. And this process takes a little bit. So if I had gone with a much lower resolution like 0.5 or 1, this process of converting it would take, 2, 3, 4 times longer, because I would have more surfaces and more geometry in each surface as well. Okay, so here we have the resulting model. There we go. And you can see what it looks like. And this is looks to me like it is a valid solid, and you can see that it is. So we could do all sorts of operations on this now if we wanted in SolidWorks, like you saw in the video. Let me close this one. Okay, are there any more questions before I go on to the next model?
Yes.
Okay.
In terms of size, is there a rule of thumb for importing organic models, Maya, ZBrush, etc.? What is a reasonable load time as an indicator that the model is too big? In my case, the asker says, I'm running a 6-core machine, 12 threads with Quadro graphics.
What kind of a model? Are they importing it as a reference mesh or?
No, there's no reference to meshes. It's just
Okay.
Organic models.
Yeah, I'm not really sure about that. It kind of depends on how you're doing and what you're doing. We can import very easily 5 million polygon meshes, 10 million polygon meshes in here, and this is obviously not one of them, but we are able to do that fairly easily, and it doesn't seem like it's certainly not like a 5-minute process to import it. It's maybe a minute or so.
Yeah, let us know
I guess,
yeah, I'm asking.
If you want to ask some follow-up later, we can get more specifics.
Yeah, that's what I was getting at. So, yeah, fill us in with more details. Okay, that was the only question for now.
All right. Now we're going to, sometimes you may actually want to modify the mesh. And so here we have a vertebrae that we got from one of the scanner companies. And this guy looks like he may have had a little bit of arthritis on this thing or something, and so let's see what we can do about kind of taking care of this and the different tools we have to be able to deal with that. So we're going to go ahead and edit the mesh, and then I'm going to sort of paint this area. And one of the cool things is we have, how we did like an isolate for finding the self-intersections and so on. Well, we have a similar tool here for working with a mesh. Now, this mesh is probably not as big a deal, but if you have 5 or 6 million polygons and you want to go and start working on it, every time you do any little operation on it, you have to regenerate the graphics, and that can really slow down things. So the solution that we have for that is that we allow you to extract a subset of the mesh, and edit it using sort of our sub-D editing tools. So now, if I turn the reference mesh off, this is actually a different kind of mesh. This is no longer a reference mesh. This is sort of like a sub-D mesh, and we can actually use all of the sub-D editing tools on it. And so what might we want to do here? Let me turn the edges off. So let's see what techniques we can do to kind of smooth this guy down. We can use a paint selection in here again, which is a very useful tool to grab that area. And one of the things that we can do here with this is that we can run a relax command on it. And you can see the relax has pulled that down fairly substantially. And you can control the relax, if it's, for example, here's 0. And so as I move up, you can see it relaxes it more down. We might have wanted to get a little bit more of an area because I can see it's right in here. It's working kind of funny. But that's one way of dealing with these sort of issues is sort of the relax command. Let me expand selection a little bit. I'll get a little bigger area here. And I'm going to use another tool. This tool is the curve. And what it will do is it will fit a surface over a ring of vertices around the outer edge. And then it will fit all of the interior vertices to that surface. So you can see the surface displayed in cyan here. And then it will fit that surface around there. So that's another way to solve a similar problem. And you can change the number of levels that you go out on the other mesh to get a better or worse curvature on it. You can see we've done it there. So that's one way to do it. That's another way. And a final way to do it is, let's shrink down our selection a little bit, is to actually go in and delete these. So if I have some bad geometry there, that might be a better solution, is for me to actually delete them. Turn off paint selection here. I'm going to grab an edge, and I'm going to use our quad fill command, which is a very powerful command, to fill that guy up again. And you can see it's done a fairly decent job there. And then once we've done that, maybe we want to expand the selection a little bit and then run the relax on it. So you can see you can replace areas of your mesh very quickly and very easily, get them much smoother, that sort of thing. And then when you're done, with that, when you're done editing, you can say accept it, and it throws it right back into the original mesh. So now it's back inside this original mesh. And so when we retopologize, it will use the new geometry we have for that. So let me go through that process, and then I'll show you some other tools that we have. Okay, we're still in mesh editing. So let me get out of mesh editing, and so we're back in sort of the level where we can do a quad wrap. And I'm going to wrap this at level 2. That's good enough for now. Now we have tools that will help you determine accuracy and all of that sort of stuff. So we're going to go ahead and shrink wrap this, throw 2 levels of subdivision on it. Or maybe just one. That's one for now. And turn off the edges. So how do we know how good this is? That's a real question, right? How do we know how good it is? And one of those ways is the distance function. The distance function will show areas in the mesh where there are issues. So right now, we have a 0.37, almost a 0.4 millimeter gap in blue. Blue means underneath. So if you look at the blue, the darker blue areas, you will see that, okay, those areas, they're going underneath. And then the red area will show where it's above. So there are sort of 3 blue areas here where we might want to do something. So let me go into, I'm just going to accept this shrink wrap for now. And then I'm going to show you a little tool here that is very useful. It's called the Selection Set Manager. And what I'm going to do is I'm just going to select a face near these areas where I have an issue. And hold down on the Shift key. So there's an issue there, an issue there, an issue here, and then probably another issue right there. So then you can see down here I have 4 faces selected. So I'm going to add that to my selection set. And then when I turn this off, you'll see them. Okay, so now I've kind of, okay, these are areas where there's something going on. And it's not quite as accurate as it should be. So if we turn on enable Zbuffering, you can see that these areas, these 3 areas here, are substantially underneath. Now, why is that? One of the reasons is that, you know, we have these big polygons coming across here like this. So we really need to add more detail or do something in that area to fix that problem. So it's actually fairly easy to fix it. I'm simply going to insert edges, and I'm just going to split these guys around here. You know, I don't have to, I can take 2 or 3 of them at a time. Okay, now, if I turn on, you can see that I've gotten pretty good. I may want to move some of these vertices sort of right on top of the sort of the transition area there. Okay, now let's see how it has affected the final result. So if we go back into subdivision mode, you see it looks really ugly. And the reason it looks really ugly is because I have the old shrink wrap data on there. So I'm going to update the shrink wrap. And so it's going to do that process again. And we will see that, oh, now it follows that ridge really nicely. And if you update the distance function, you will see that this is no longer blue like these guys over here. So let's turn that off. So we got a couple more areas over here we may want to fix and address. Some of these we can do fairly easily. Like this one, I think I'll just move that edge kind of to the top of the ridge. And here as well. I'm just going to kind of move these vertices to the top of the ridge. Oop. There we go. And if we run it again, if we update our shrink wrap and show it in subdivision, you can see that we have solved that particular problem. And then we still have this one over here, which I think I can fix very easily. And then I will update the shrink wrap. Yeah, I went too far. But you get the general idea of how to fix up the meshes, make sure that, you know, check the area, check the distances and that sort of thing. And you can use the distance function. Okay, whenever I use this distance, if I recalculate, it will update my distances. So actually I got worse. Okay, sorry, I got worse. So let me fix this guy here for real. And then we will, we'll fix it. We'll check it out. Okay, you can see why we got worse. And maybe we should add another edge in on here, just because that was getting a little large. Okay, now that looks a little better. So here, and you know, this is sort of the price you pay if you decide to try and keep your quad wrap levels low. We wouldn't have had any of these problems if we went a little bit lower in the quad wrap. They would have all, you know, we would have had enough polygons to get over this. So this really is only applicable for cases where you have the quad wrap. So if we recalculate here, now you'll see that we dropped the minimum value for the current distance from like 4 to 0.15. So it's 0.15 on both. I mean, you could keep going. You know, there's a few areas here where you might do a little bit more. The other thing that you could do is you could always go up a level in your shrink wrap and subdivision levels here and see what happens as well. Okay, let me, oh, I forgot to say show preview. No wonder I didn't see anything happen. Okay, so when I run another level in shrink wrap, it did drop it down somewhat more. So that gives you sort of an idea of how to refine your mesh and work with it. We have some very nice tools for doing that. I never did use the selection tool, but you can use the selection tool to reselect those faces that you, so you know kind of where the issues are. All right, any questions before I go on to a new model? Have we doing for time? We got about 2 minutes left.
Yeah, but don't worry. I mean, I have, you know, we have extra time. I don't know about you, Gary.
Okay.
If you want to linger, we'll be happy to have you linger a little further. So we've had a follow-up for the previous question that was posed by Justin, and he says, in my case, I've had difficulty with both small, high poly count ZBrush as well as very large car size Maya models that would end up, well, converting to a SolidWorks solid. And he thinks you answered the question in that waiting around for 10 minutes, it's not the norm. So,
okay.
Okay. And then another question is from Chris. It says, your complex operations are working exceptionally quickly and smoothly. And what kind of computer are you using? Normal laptop, engineering workstation, and what are the approximate age and specs, please?
Okay, I have a very good computer.
Okay.
However, my fellow employee has a Lenovo Quad 4 laptop, and we rerun these operations on that. They run almost exactly at the same speed. So it is parallelized. All these operations are parallelized. So if you bring up your process, you know, monitor there, you'll see that we typically during a lot of these operations are using 100%. But I guess 100% of 4 cores and 100% of 10 cores, there's probably not a huge difference there. So I have a 10-core machine here. So it is a pretty beefy machine.
Great. And I don't know.
It doesn't run any faster. Of course, the problem with the 10-core is that the clock speed is slower than the 4-core. So the basic operations are a little bit slower.
Okay.
So
it
ends up being very close to what the laptop runs. I mean, within 5%, 10% of what the laptop does.
All right. I don't know if you know about this, but at Novedge, we offer also customized CAD workstation. So you just call us and tell us what you need, and we customize everything. So in case you want to emulate Gary and his workflow. And we have another question. Power
Sure.
surfacing reverse engineering works very well for organic models. How does it do with contoured sheet metal? Think vehicle surfaces where you are also trying to capture the shape edge of the panel as well as the overall shape.
Okay. We have had customers send us some of those, and typically what we will do, typically it's kind of a very squarish thing. And so what we will do is lay out, so let's say it's, you typically have something fairly flat with a bunch of holes in it. And so what we do, we typically will fill those holes in, and then, they tend to be very flat. So we may, for example, just put a square on top of it, and then subdivide that square to get the same thing that we're doing here, instead of using the quad wrap. I mean, typically those, you're a little better off if you lay out the mesh by hand, which you can do fairly easily. So for example, let me show you how you can work the mesh by hand. So you might do something like that, and then draw edges. You might paint faces. So then you can just boom over here, boom over here, boom back here, maybe like that. And so then you can use these sort of techniques to quickly fill in. That was kind of nasty there. So let me grab that and just pull that guy out. So, oh, come on, I'm not in a very good viewport here. Okay, here we go. Oh, no, wait, what happened? This guy jumped to the bottom. No wonder it was bad. All right, so here, we'll put him on the top. All right, so we can grab like this and do our fill and that sort of thing. So it's fairly easy to re-engineer something like that. So typically we'll go outside around the outer edge, and then we'll do some fill operations. And then when we're done, we'll recut the holes with SolidWorks. So that's how we operate on those. Does that make sense?
Cool. Yeah, absolutely. Last question. What are the major differences in capabilities between the SolidWorks and the standalone version?
Not much. I would say the main difference is that you're exporting to a step file, and you don't have your SolidWorks geometry right there with you. In other words, you can't easily create a cylinder and import it and use your SolidWorks tools on it. But for purely organic shapes, like for this guy, probably wouldn't be necessary. For reverse engineering, the one we showed you about the topology optimization model, where I had to bring in some cylinders and constrain to those and those sort of things, sort of those mixed operations where you need some real geometry to go with it. For example, let's say you're building a some kind of figurine that sits on a surface, and you need a plane for the bottom. In SolidWorks, it's real easy to go and select that plane, put your stuff on that plane, and then build it up from there, or cut it, or that sort of thing. So that's the main difference, is that you have to do all your CAD operations after you import it to your CAD system. And so it's just a little bit, just a little bit different workflow.
Thank you,
but
Gary.
You can do all the other things.
All right, that was it. That was it for question for now.
Okay, well, let me just run this last one really quickly. Sure. And we will I want to show you how we can capture. See, this model has an amazing amount of surface detail in it. So I'm gonna show you how to capture that. Okay, I'm going to ignore this stuff. I can fix that fairly easily. So let's turn the edges off and turn it into subdivision mode. Okay, you can see I haven't got a lot of detail in this area, but once I go into shrink wrap and apply level, let's try level 1 of shrink wrap on it, and you will see it quickly pop out to get pretty much all of the detail on the surface that is inside of the actual model. Okay, you can see those veins and everything popping out really well now. Let me go one more subdivision on it here. So let me get a good view here, and then we can hide the faces, and so you can see that we have captured all of that fine detail. So there's like these veins in here. When we turn this back on, you'll see those veins come right in there. So you can see all these veins coming in there. One of the things we do is if we turn off the optimization, you'll get a little bit more detail, because then it doesn't try and smooth out any areas at all. It will give you a very heavy mesh when you're done, but you'll get more detail. There we go. So you can see it has picked up all of that fine surface detail that is in there, as well as, you know, all of this stuff in here. So that's it. Any final questions before we sign off?
Yes. Does power surfacing RE also includes the feature of power surfacing 5.0 for SolidWorks?
Yeah.
Okay.
That's an easy question. The answer on that is yes.
Good. We like that. And what a file format is best to bring in?
Typically, OBJ files are the best. STL will work fine. So either of those works. The other thing that you can do, which is kind of interesting, is that you can select a SolidWorks model and produce a mesh from it and reverse engineer it.
Awesome. Okay, now that was the very last question.
All right.
All right. So thank you so much, Gary. I'll take the screen back to wrap it up. Is that okay? Are you done?
That is perfectly fine.
Just making sure. Let me share my screen again. And I want to thank everybody for joining us today. And I want to remind everyone to visit novedge.com, where you can find Power and power surfacing and all the products. And I also want to remind everybody that we will have upcoming webinars on Cyber 3D, since somebody was interested. So stay tuned for that. And I also want to remind you that we are on Facebook, Google+, Twitter, and that this session is being recorded and will be posted on YouTube as early as today. Thank you so much, Gary. And I was very impressed. Power surfacing is a great solution. And as Gary said, is a solution that nobody has. So check it out on novedge.com and give us a call anytime. We're here and we're listening. Thank you so much, Gary. And I guess I'll talk to you soon in an upcoming webinar in the next couple of months.
Okay, great. Thanks.
Bye, everybody. Bye-bye.